Williams Fire and Hazard Control's tenure in the marketplace includes a long history of beating the odds and taming the largest industrial fires the world has ever encountered. Since the oil boom burst forth in the Spindletop oil fields near Beaumont, Texas in 1901, industry has faced the daunting task of extinguishing fires that were immune to municipal firefighting tactics. These events came with an enormous toll in loss of infrastructure, raw product, and at times, human life. Due to the extreme nature of these fires and the lack of proper response capabilities, owners were forced to stand by, watching helplessly as hard-won assets burn themselves to depletion. As time passed, those brave enough to confront these fiery threats continued to find the proper tactics elusive and the dangers simply overwhelming. With the advent of protein and then synthetic foams, industry found a new medium for suffocating these fire-breathing dragons. Then, in the face of the massive scale of these industrial-sized incidents, application tactics took a huge step forward with the efforts of Williams Fire and Hazard Control, who introduced the self-adducting nozzle, hydrofoam and hydrochem equipment, large volume fire field hydraulics, and footprint Type 3 applications. From its earliest days, Williams Fire and Hazard Control's mission has been to overcome these extreme challenges, to develop the successful tactics and specialized equipment that have now defined an industry for over 30 years, by making proactive flammable liquids fire response a viable solution. Inherent in every development to come out of this Texas-based company is a dedication to build safety, efficiency, and tactical advantage into each piece of equipment they manufacture, to minimize risk and maximize success. Williams' latest research and development project addresses the escalating complications involving tank response logistics, staging, and resource demands, considering engineering practices that are now commonly driving tank sizes over 300 feet in diameter and often exceeding 400 feet in diameter for open floating roof tanks bearing crude oil, key factors affecting successful response efforts. Therefore, Dwight Williams of Williams Fire and Hazard Control has devised a new dual attack system that addresses both seal fire and fully involved fire scenarios from the tank rim. Introducing the Ambush, a component configuration of Williams Fire and Hazard Control's Tank Battalion series of integrated storage tank response equipment. Holding to a lifelong commitment to offer fire response personnel an unfair advantage against seemingly insurmountable odds, the Ambush system is designed to minimize personnel exposure and logistical considerations in the face of one of industry's most complex fire response scenarios, the fully involved storage tank fire. These incidents require consumable resources, often unimaginable by corporate and fire response entities. The network of response agencies, supply logistics, experienced manpower, and on-site tactical management are daunting, even for an experienced command structure. In the face of these challenges, the Ambush system provides a systematic approach for delivering Williams' successful footprint foam applications from the rim of these mammoth tanks. Williams Ambush delivers a powerful foam application aimed at two distinct hazards within a tank, a seal fire and a fully involved surface fire. Traditional foam pourers drop foam down the tank wall and rely on gravity, molecular weight, and self-leveling of the application below to slowly push the foam outward along the perimeter. The lateral nozzles of the Ambush system shoot foam down and along the tank wall, inundating the seal area with a foam application that maintains a flow velocity far greater than traditional foam pourers or foam chambers. As the applications from neighboring lateral nozzles converge, they force the foam toward the center of the tank. In the event of a full surface fire, the gusset nozzle sitting atop the Ambush unit may be engaged to propel a Type 3 foam application toward the center of the tank that will meet opposing nozzle applications at the center. Creating a dense foam blanket, this footprint mounts from the center back toward the tank wall to meet the seal application, each working together to extinguish the surface as they grow. In the test scene here, 6 ambush units are mounted equidistantly around the rim of this 277-foot open floating roof tank. As the system is charged and foam comes online, the collective flow rate reaches 9,000 gallons per minute, 1,500 gallons per minute per unit, with a resulting foam application density of 0.1493 gallons per minute, fully covering the surface in approximately 1 minute and 30 seconds. Although these systems have been designed to address challenges presented by industry's largest tanks, the ambush system offers a logical response solution for smaller tanks when lack of water resources and experienced response personnel may be a factor.